Hello students, welcome to the week 6 example videos. We are almost there, over halfway now. So today we're going to be making this little part with our base and then our little rectangular bucket shape on top. So I'm going to suppress this real quick and then also go to the sketch. So here's the sketch that's also in the slides. Okay, so when creating this, you must first start with the game plan. Okay, so first we can see the coordinate system is here in the middle and also on top of this bottom part because we have a bottom slab and then we have this top bucket shape. Okay, so what makes sense to do is to start, obviously on this top view plane and then create this rectangle and also the inner rectangle because both can be started from there. Okay, so that's what we're going to do. We're going to draw this 300 by 250 and this 150 by 125 rectangles. Okay, so sketch and start on the top view. Oh, we also received a question and we realized that we never actually discussed it. To move around like this, you must hold in the middle mouse button and then move your mouse around it, then you can move the part like this. I presume everyone figured it out by now, but yeah, that's how you do it if you were wondering. Okay, so let me just go back to the top view and let's start with those rectangles. Okay, I'm going to use this tool again because I know the center point, so there should be what, like 300-ish and what, 250. It doesn't fit on the screen, so I'm just going to make it smaller and not worry about it and finish it or change it later. Okay, so this should be 300 and this should be 250. Then this is, I believe, 150 and then 125 for this one. And then before I say finish sketch, there's one more thing. So we have these holes on this slab and they are, we give a distance from the edge, and we also say over here from this detail view that it's a 10mm ISO drill hole. So you must know then you should use the hole feature or hole function rather, whatever you want to call it. So you need a point to reference from. So while we're on the sketch, we can add this reference for where to start. So this is 31.25 from the horizontal. So I'm going to add a point, click it there, and say, okay, this should be 31.25, and it didn't do anything. 31.25, there we go. And from the vertical, it should be 37.5. 37.5, there we go. And also I said, okay, this is a typical length, so that means this is also 31.25, and this is also, and this, and this one's 37.5, typical. So the same for all of these. Okay, so that's in. Sketch is fully constrained. We can finish. Okay, I'm just going to move this to this view. Okay, so first I'm going to add the base. So we extrude. How far do we extrude? We extrude 20 downwards from the origin. So go down. Oh, but we want this as well. It's a solid slab. And we want to go 20 down. There we go. That looks great. Then we can apply that. And while we're still in the extrude function, we can now also extrude our little bucket. So you can see here it has a thickness and it's also drafted. Okay, so when I originally wanted to give this to you, I wanted to make it or do the draft and the offset in one go. But then I realized, or then I saw that NX didn't allow me to do that. So let's first say, okay, we want to use this face. Actually, I don't want to use that face because it's a face of the extrude. I want to use this sketch area. So I just hid the extrude, and so I could select the correct shape. Okay, so now it should go up 120 from the bottom. So from the origin, it's only 100. 120 minus 20 gives 100. So we go up 100. There we go. Now, if you try to, we can say start limit, that's fine. Section limit, start limit will give the same if you go in the same direction. So if, and also, okay, it's already on 2 degrees. So you see 92 degrees, so it's 2 degrees from the vertical. So that's already set in. Now, if I want to say offset, okay, two-sided offset, and I want to go in by 10 millimeters, and that's all round, typical, then you might think, oh, it worked. But if you look carefully, you see, let me change my view. That works, but this works better. You see, it created a little pyramid. It's not slanted to the inside for both. Both are drafted from their respective verticals. So it will all go to a point. And that's not what we want. And if you went the other direction, you see it did that. Okay, so I'm just going to take that back to 2, and then I'm going to take away this draft. But we're still going to use the offset tool. So let's say apply. Now we have our little block there. I'm just going to hide it again and select this again and show it again. So now I can say start limit, draft again. I want to subtract, but now I can single-sided offset -10, so 10 towards the inside. So now it essentially, let me say none. So now you can see it creates this shape. So it's essentially the same one as what we did previously, just a little bit offset from the outside, a little bit smaller. And then we can just then subtract that from the original, and that's our shape done. One thing I did not mention, yeah, we united these two during that extrude. Okay, almost there. So this is a very quick part. So then we're going to go over to the holes first before I get to the chamfers and so on. So by the way, for video 2, the code word is the Z coordinate of the center of mass of video 2's part. Okay, so the holes already have my reference point over there. So then I can use the hole feature. And then you see, so if you go to simple, then you have custom, so you can select drill size because we have a ISO drill, and it's a 10mm ISO drill, so you should just go through all of these. There's a bunch of them, but you want to select 10mm. Fit, exact or custom. I didn't specify, so you leave it at the standard settings. Okay, specified point over here. Yes, we want to use either the sketch or the existing point. It's the same one, as you can see, is point of sketch. So I'm just going to say existing point, that's fine. Normal to face all the way through the body, and obviously subtract it from the shape, from this body. You can say show result to check, and then okay. So here you can see it adds its own little chamfer on both sides when using that specific setting on that tool, the drill setting specifically. So now we need to add our other holes. So for that, we're going to use both our pattern and our mirror feature. So first the pattern feature. So specify our vector is linear. I should probably first say which feature. So the drill, and then say, okay, we want to go in this direction, and this is 31.25. So 31.25. The code word for my video is whistle. Then you say how many you want to go. So yeah, I see, okay, it's going too short. I need 7, not 6. So let's type 7 in there. There we go, it goes all the way. Then I can apply that. So now I can create the holes in this direction. So I select, again, this one, specify vector, this direction this time, and this time it's 37.5. But I don't want 7 holes, I don't want to go all the way, because when I'm mirroring this, then I don't want 2 holes intersecting one another. That can cause problems. So I'm just going to say only 6, so it's 1 short, and say okay. Then I'm going to mirror both the pattern and you can just see, yes, so I need to hold in either shift or control, it doesn't matter because they're next to one another. So select both of them, and then I want to mirror them around this plane here, the YZ plane. Yes, the YZ plane. and you can see the little dot where it's going to mirror it. You can say show result. That's correct. Apply. And that's also one of the reasons why you put the coordinate system usually as central as you can, because then you can just use the existing coordinates to mirror around or to use as your reference. I'm going to speak about datum planes in a moment. I believe I showed that in the first example of last week, but I'll just quickly recap that again, because well, you can do the homework without datum planes, but I would not recommend it, as it is quite a bit more difficult if you don't do that. So now I'm just going to mirror the pattern here in the middle, because it's already, these edge ones are all the way there. So now I want to use the XZ plane and then show result. There we go. Okay, then we're almost finished. This is really a very easy part to make. So we have two types of chamfer. We have this symmetrical chamfer here. If I don't specify, it's symmetrical, but sometimes I will just specify. So it's a 5mm symmetrical chamfer all the way around this part. So I'm going to go to chamfer. This is 5, not 45, 5mm. Then I can select these edges. All of them selected. Okay. And also the reason I'm first chamfering that edge and then the other one is because you can see these chamfered edges, because yes, it said the top shape is open, yes, at the top, at the bottom. You can see that. And then all edges, yes, so the other chamfer, so all edges except for the holes are broken with a 1mm chamfer. So that's after you've built something, especially if you've built it from let's say sheet steel that got welded together, or parts that got machined or so on, you get rid of any burrs. So you just take any sharp edge and just run it over with an angle grinder or something, just to break that edge, so that your customer doesn't cut their hands on it. So here you must use logic. Okay, so I said all the edges except for the holes, because they already have the edges broken. But that doesn't mean these inside edges, because they are not sharp. Okay, also doesn't mean these edges, because they are not sharp. They are pointing essentially away from you. It's all the pointy edges, if you want to put it that way. Okay, so you must use common sense there. Okay, so just also, I don't specify, but since I didn't specify, it's symmetric, 1mm, and now all these protruding edges. And you can do this in one file swoop. Don't, bloody thing. Okay, I accidentally clicked on something, so I'm just going to start over, and this should be 1mm, not 5mm. So let's try that again. No. Okay, so if you accidentally select something and you want to unselect it, hold in Shift and click on it again, and it will unselect. So now just select all of these edges and extend its pop-ups. Also want to take these ones, because they're also all protruding edges. That one, these ones. Okay, then also these ones, because if you're running it over with an angle grinder, you're just going to go all the way. Okay, you might want to be careful, but just as you can see, I'll show you again in the picture in a moment. You can see it goes all the way down, chamfering everything there. So now I can see, I'm just going to go back into this one and check that I selected all those protruding edges. Yes, I did. So now I can just go back here. I can actually go to model view and isometric, and then we have this part. There we go. Very easy. Oh yes, datum planes. Almost forgot about that. If you want to add a datum plane, you can add it multiple ways. So you can say, first of all, I believe I did do this, but at a distance. So select this plane, and then it will add one at a distance. So this shows the distance in which, or the direction in which you're going, and this other arrow is showing the top of that plane. Okay, so if you're going to make a sketch, it's going to be on the top, it's going to be on the arrow side of the plane. So it's essentially, if you want to draw on this plane, you're going to be drawing like this, obviously not askew. Then you have at an angle, so you can also say, let's say this plane again, and linear object, so I want to rotate it about this one, and then you can add an angular one. You can also say bisector, that means between two faces. So select plane 1, select plane 2, adds one in the middle. Obviously this will be redundant here because there's already one, but if you're going to if the origin is not in the middle of the two faces in which you want this datum plane, then you can just add one like that. Those are the most common ones. You can use a bunch of other ones, but those are the basics. Okay, so just cancel. That's datum planes. And yes, that's example 1. So good luck. I urge you to try this one. It's really quick and easy. Then also obviously watch the other videos, try them as well, and then the homework. The homework is a bit more technical than it was last week, but you have all the principles you need to be able to do it, and if you just put your head down and work, you will be able to complete it. There are different ways of doing 3D modeling. So for instance, when I because I also did the homework too as well, just to check if everything was there, and I did it a different way than Janika did it, and we both got the same result. So there are many ways to skin a cat. Don't get discouraged, really try your best, and you will succeed. Yeah, enjoy the rest of your day.